Ionic bonding is caused by a metal and a nonmetal. They are stronger than covalent bonds, which is formed by two nonmetals. The bigger the difference in electronegativity, the more ionic the bond becomes. Partially ionic bonds partially ionic bonds are called polar covalent bonds. It is a type of chemical bond where two electrons are shared unequally between two atoms. So the electron is shared unequally between the two. Non-polar covalent bonds are a type that occurs when two atoms share a pair of electrons equally between the two of them. When many atoms get together, the positively charged ions arrange themselves to form large ionic crystals. This shape multiplies hundreds of times until it forms a crystal.
Atomic radius is the radius of the atom when we make the atom model as a circle like this. It changes the size when it combines with other atoms. Atomic size increases when we go down a group here, but decreases when we go across a period left to right here. If we go down, orbital split and increase the size. If we go across period left to right, nucleus charge withdraws and the valence electrons increases and makes the size bigger. Therefore, the smallest atom is helium here, and the largest atom is francium. Electron shielding effect is the electrons push each other because they all have same negative charges. It decreases the nuclear attraction. The larger the shielding effect, the easier it is to lose electrons. For example, hydrogen has only one electron, which is the least reactive atom in periodic table, and lithium has 3 electrons, which makes it more reactive than hydrogen. So shielding effect is related with electronegativity. If an atom is electronegative, it means it's good at taking away electrons, and if it's good at taking away electrons, you will need higher ionization energy to remove the electrons. Is related with electronegativity. If an atom is electronegative, it means it's good at taking away electrons, and if it's good at taking away electrons, you will need higher ionization energy to remove the electrons.
So today I'm going to be explaining ionization energy and electronegativity. So this is a lithium ion, and this is lithium. Lithium turns into this lithium ion. It turns into a lithium ion because of ionization energy. Ionization energy is how good an ionization energy is energy required to remove an electron. So since lithium is a smaller atom, it has less electrons, it's actually harder to remove an electron because it has a way stronger pull onto electrons. But eventually it turned into this lithium ion. Okay, next thing I want to talk about is electronegativity. So here we have fluorine, which has 9 electrons. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the nucleus. So the definition of electronegativity is how good an atom is at taking away an electron. So here fluorine has 9, and instead of giving off an electron, it'd be better for it to gain an electron. So here, fluorine actually changes from that into this through electronegativity. And the reason fluorine is one of the most electronegative elements on the periodic table is because fluorine is a small atom, and therefore its nuclear has a stronger pull on the electrons. So since it's also good at keeping its electrons, it's also good at taking away electrons from other atoms. And then lastly, I'd like to explain why noble gases aren't electronegative. And the reason noble gases are not electronegative is because they neither want to give away an electron nor they want to take away.